Hey everyone, and welcome. Today, we're going beyond just digital money. We're going to look at the tech that could totally change how the internet works. We're talking Ethereum, smart contracts, and the whole world of decentralized apps.
You know, when most of us hear blockchain, our minds jump straight to cryptocurrencies like Bitcoin, which, don't get me wrong, is a massive innovation. But that got people thinking, what if a blockchain could do more than that? What if it could actually run code, enforce agreements, and become the bedrock for a whole new kind of internet?
And the answer to that really big question starts with our first idea. Thinking about Ethereum not just as money, but as this kind of global shared computer, a world computer, if you will.
It's a totally fair question, because the idea can feel a little out there at first. Is it a currency? A platform? What's the deal? Well, truth is, it's kind of a little bit of all of those things. Okay, at its heart, Ethereum is a decentralized system. That means, just like Bitcoin, no single company, no government, no one person is in charge. But its goal is way bigger. It was built from the ground up to be a foundation, a new layer for an internet that could fix some of the big problems we have with today's web.
Now, for anyone who's worked with traditional databases, this is where it gets really interesting. Normally, you've got a client-server setup, right? All the data sits on a central server that one company controls. They can change things, delete things. It's a top-down system. The Ethereum blockchain is the complete opposite. It's a flat, peer-to-peer network, a distributed ledger. Nobody's the boss. And here's the kicker. The data is immutable. Once something is recorded, it cannot be changed. It's there forever.
All right, so we've got this global computer. But how does it actually do anything? Without a central admin running the show, how do you enforce any rules? Well, the answer lies in our next piece of the puzzle, smart contracts.
And this is really the crucial question. In the real world, we need lawyers, banks, all sorts of middlemen to make sure people stick to their agreements. So how in the world do you do that on a network where you don't have to trust anyone?
The secret sauce? It's code. A smart contract is basically a program that automatically carries out an agreement. The terms, the if this happens, then that happens logic, it's all written right into the code. And because that code lives on the blockchain, it just runs. It runs exactly as it was programmed, without any chance of being censored, shut down, or messed with by some third party.
And because these contracts are on the blockchain, you get some pretty powerful features right out of the box. Every transaction is traceable and totally transparent. Once the conditions are met, the outcome is irreversible. And the biggest deal of all? You don't need a central authority to oversee anything. The network itself becomes the referee.
Okay, so we have the world computer and we have the automated rules to run on it. Now for the fun part. What can we actually build with all this? That brings us to the world of decentralized applications, or DApps for short.
So what's the end game here? What's the point of all this cool underlying tech? What are people actually making on top of Ethereum with these smart contracts?
They're building DApps. Now, a DApp can look and feel just like a normal app on your phone, but it has a radical difference under the hood. It's designed to connect you directly to whoever you're interacting with, totally cutting out the middleman company that usually runs the show and, more importantly, controls all your data.
Let's make this super clear. Think about a regular app, say Twitter. The company is the middleman. They control the servers, and they can delete or censor anything they don't like. A DApp version of Twitter would be totally different. It connects users directly, and once you post something to the blockchain, it can't be erased, not by anyone, not even by the people who created the app. This makes it incredibly resistant to censorship. The control shifts from the company to the users and the network itself.
So, as you can imagine, this has kicked off a whole ecosystem of new kinds of apps. But, they're not all the same. We can actually break them down into a few main categories based on what they're trying to do.
Yeah, you can pretty much sort dApps into three main buckets. Type 1 is the simplest stuff, apps that just handle money between people. Type 2 gets a lot more interesting. It mixes money with information from the real world using these special tools called oracles. Think of a crop insurance app that automatically pays out if a trusted weather feed says there was a drought. And Type 3 is all about governance, using the blockchain for things like voting, well beyond just financial transactions.
And this leads us to what might be the wildest, most ambitious idea in this whole space, the Decentralized Autonomous Organization, or DAO. Just try to picture this. A company with no CEO, no board of directors, a totally leaderless organization. You write all the rules into the code from the start, how to vote, how to spend money, and then you just let it run.
governed entirely by that code and its members.
So let's just zoom out for a second and look at the path we've taken. We started with Ethereum, the world computer. On top of that, we layered smart contracts, the automated rules. With those rules, people are building DApps, apps without middlemen. And the craziest version of that is the DAO. All of these pieces, all these building blocks are pointing in the same direction, towards a more decentralized, user-controlled internet, what a lot of people are calling Web 3.0.
I mean, this technology is all about shifting power, right? It's about moving control away from a few giant corporations and putting it into the hands of a distributed network of users. It allows for new kinds of apps, even new kinds of organizations we've never seen before. Now, it's not without its own challenges, for sure, but it leaves us with this huge question. Are we looking at the very beginning of the next version of the internet?
And that's our deep dive for today. Hey, if you found this useful, do us a favor and hit that like button, share it with a friend, and definitely subscribe for more explainers just like this one. Thanks for watching.